Hi everyone, today we're going to talk about single replacement reactions, how to recognize them, and how to figure out what products you're going to get when you have a reaction. Okay, so the first thing we need to talk about is what is it? A single replacement reaction is when one pair of elements, a binary molecule, separates and joins with a single element. Okay, in the most simplistic explanation, I have element A meets compound BC. Now, what's very important to understand is whether or not you're dealing with anions and cations. Okay, we'll talk more specifically about that in a second. But in this particular instance, I'm going to have product AC plus B. So they are flipping spots. Okay, so we're going to talk about four types of single replacement. Okay, the first type is going to be metal to metal. Which is what I've shown at the top here. I've gotten metal A plus compound BC, and in this particular case, both my A and my B are my metals, my cations. So I'm going to end up with AC plus B. Okay. Second type we're going to talk about is when a metal replaces hydrogen from water. So in that particular case, I've got some type of a metal plus water. Okay, and the most prime example of this is an alkali metal in water. Okay, you put sodium in water, lithium in water. What you end up with is a metal hydroxide plus hydrogen gas. Okay, third type we're going to talk about is when a metal replaces hydrogen from an acid. So some type of metal and some type of acid. It could be a binary acid, could be a polyatomic acid, but your result is going to be that metal ion with whatever was bonded to your acid plus hydrogen gas. Okay, and the fourth type we're going to talk about is the opposite of type 1, except it's the anions. This is going to be halogens. So I've got a halide to halide replacement. So if I have, say for example, C plus BD, where my C and my D are my halogens, then I have BC plus D. Okay, so like I said, the more important part of all of this is making sure you don't get your positives and your negatives mixed up. Okay, so let's do an example of each so that we know what our products are going to be. So I'm going to start with calcium plus zinc sulfate. All right, and this is metal replaces metal, so I'm going to get calcium sulfate plus zinc. So now I'm going to write my equation. I've got calcium and zinc sulfate. Zinc is a +2, sulfate is a -2. Put them together, I get ZnSO4. My 2's will cancel out. Calcium sulfate, calcium is a +2, sulfate is a -2. Put them together, I get CaSO4. My 2's will cancel out, plus zinc. And balance it, and it is good to go. All right, let's look at number 2. Number 2 was metal replaces hydrogen in water, so I'm going to put sodium in water. And if you remember, my result is going to be metal hydroxide. So my metal is the same, sodium hydroxide plus hydrogen. So sodium Na plus water, H2O, yields sodium is +1, hydroxide is -1, I get NaOH plus hydrogen, diatomic H2, and to balance this, it's going to be 2 sodiums, 2 waters, and 2 sodium hydroxides. Okay? My third type was a metal replaces H from acid. So this time I'm going to do, again, sodium. And I'm going to use phosphoric acid. I'll try to write a little smaller this time so I don't jumble up my words. Phosphoric acid. That's going to make the metal ion of the acid. So that's going to be phosphoric, means phosphate. So sodium phosphate plus hydrogen. Alright, sodium, Na, phosphoric acid. All acids have an H. Phosphoric means phosphate, so PO4 minus 3. That gives me H3PO4. That's going to be sodium phosphate. Sodium is a +1. Phosphate, PO4 minus 3. Na3PO4 plus diatomic hydrogen. Okay, this one's actually a little bit trickier to balance, but once you get it balanced, it's 6 sodiums, 2 phosphoric acids, 2 sodium phosphates, and 3 hydrogens. Okay, and the last one is halide to halide replacement. We're going to use fluorine plus sodium bromide. All right, now again, know your halogens, know your pluses and your minus. This is going to end up being sodium fluoride plus bromine. So fluorine, diatomic, F2, plus sodium bromide. Sodium is a +1, bromine is a -1. Put them together, NaBr yields sodium fluoride. Sodium is a +1, fluorine is a -1. Put them together for NaF plus bromine diatomic, Br2, and that should just be 2 NaBr and 2 NaF. Okay, now, like I said, knowing your positives and your negatives is the most important. The biggest mistake that I always see with type 4 here is that people will try to make fluorine plus sodium bromide, and they'll try to make some strange combination of fluorine bromide. But as long as you understand your positives and your negatives, and you know that that's a negative and that's a negative, and like charges repel, they're not going to go together. Okay, so this is not going to happen. Okay, so know your positives and your negatives. There's just those 4 types. Okay, you've got your metal to metal, metal replace H from water, metal replace H from acid, and halide to halide. Okay, and that's about it. Next class, we're going to look at double replacement and combustion reactions. Until then, remember, work together, help each other, and make the world a better place. See ya.